a magic tap. I don't know where it light from outside, objects from falls from a phone. This is a hyperbola and the disc. How does it go through the curved slot? When you see a tube, but this is a fish one. Ah! Oh friends, welcome back to my channel Crazy Sanskriti Vlogs. Today you are going to explore the whole science park with me, which is at Bhubaneswar. So before we start, I wish you all a happy Earth Day. So let's go and explore the science park. Friends, take a look at me. I am an astronaut. I am going to fly into space. Friends, look at that. Is the much huge snail that I have ever seen, and that's the biggest tap I have ever seen. Really, water is coming also. I wish this tap was in my home. Okay, guys, this board is talking about the globe sculpture, which is there. It's telling that stand on the footmark and look at the globe for some time. Can you see well-arranged patterns that form a portrait? Portraits of two famous Indian scientists are hidden in the sculpture of the globe. One of them is identifiable from here and the other from the right side of the globe. Can you recognize the scientists? Okay, let's go and recognize the scientists. Okay, so let's go to the globe sculpture. Oh, we can't go to it, so let's go in this way. So this is the globe sculpture. I can't recognize any scientists, but if you can recognize any scientists, please comment down. So guys, this is the magic tap. I don't know where it is really magic or not. Here it is written. Yeah, the water is coming from nowhere. That's why I call it the magic tap. See, there are no pipes here and all. Can water come from nowhere? Do you think it is possible? If it is not happening, then what is happening there? Okay, we will find out when I go home. But how water is coming from that side, I can't understand. And the water is sprinkling on me. So guys, the thing we are seeing right now here is known as the simple camera. Whenever you watch through this hole, the things get very closer, but it is upside down. Let me check. Yeah, really it's upside down. You can show in the camera. Look into the box through a circular opening at one end and see the beautiful colored image. Rotate the box slowly and watch the image changing. Observe that the image is always inverted. Light from outside, objects falls from a frosted screen through a lens and forms an inverted image. In a simple film, it is kept in place of the frosted screen. Now, so guys, this thing you are seeing is known as a sundal. In ancient times, we used this. Sundals have been used since ancient times to measure the local time. The inclined rod is the gnomon of the sundial. The gnomon is inside of Bhubaneswar. It is aligned in north-south direction and points towards the pole star. The local time at Bhubaneswar longitude is ahead of Indian Standard Time, reference longitude 18 by about 13 minutes. A correction is therefore to be added to the time shown by the sundial. Sundials works on the basic principle that shadow of an object changes position as the sun apparently moves across the sky. So here it is telling that when the sun moves across the sky, in ancient times we used to measure time in this one. Okay, let's go and explore the other things. So guys, this and that are known as lithophone. That is a lithophone, and as well as this is a lithophone. Okay, let's try how it sounds. So guys, I know you would be hearing the sound of this lithophone. Okay, let's try that one. I know I'm not playing very well, but I tried to do that. Okay, so here what you do, the lithophone, hit the metallical bars of different lengths gently with the striking hammer. Observe that the different bars emit sound of different pitches. The pitch or frequency of sound generated by striking a bar depends on its length. The shorter is the length, the higher is the pitch. Here, the lengths of the bar are such that the frequencies generated by them are in a musical scale. You can play sa re ga ma by striking them from left to right. Now strike the granite bars and notice the different sound in quality of sound. Okay, so this was very interesting. Let's go and play in that one. So guys, this is a potential well track. Press the lever and release the two identical balls to roll down the tracks. But here there are no two balls, there is only one ball. Observe that the ball in the dipped track reaches the other end than the earlier than the ball moving along the straight track. Although both the balls initially start rolling down from the same height, the ball dipped in the dipped track further gains in speed while descending down the dipped portion of the track. It covers that the larger portion of the track with its enhanced speed and hence reaches the end ahead of the other ball, even slightly slowing down while climbing upwards the end of the track. Okay, so let's try. There is only one ball here. Okay, let's try this one. So this is I think this is the dipped one and that is the straight one. Okay, so let's push it. Whoa! It's going so fast! Nice. Can we take out this ball? Okay, now I will run with the ball. Just follow me. Come here. Oh, it came! Guys, this is a echo tube. It's very long. It starts from this end till that end. If you say something here, then it will be soundable to that portion. Okay, let's read this board. Bring your mouth inside the tube and say hello. You will hear a distinct echo. Similarly, clap once and hear several echoes. Sound waves travel through the tube at about 330 meters per second and come back reflected from the other end. You can distinguish an echo if the reflected sound arrives at your ears at least 1/10 of a second after the original sound. Okay, so guys, I'm going to that end and you will in this end and try to hear me. I'm keeping the mic here. Okay, I'm going. It's so long!
Hello,
Guys, can you hear me?
Hello, Sanskrit.
Hi! Okay, so are you able to hear it? Let's move on to the next one. So guys, this is a hyperbola and asymptotes. This is such a weird name. What to do? Rotate the knob to spin the inclined rod fitted in the disc. How does it go through the curved slot? When you spin the rod around, it traces a three-dimensional shape called a hyperbolid from a hyperbola. The curved slot that you see is cut in the exact shape of the hyperbola so that the rod passes straight through. Hyperbolas are conic sections. If you take two cones that are standing tip to tip and slice straight down through them, the curves on the resulting flat faces will form the branches of a hyperbola. Same curves are known as mura or muda in local parlance. Okay, so let's try it. Okay, I'm trying it. I'm sure you all have tried. Whoa, it really works. Okay, let's turn this side. Wow, so nice. Okay, these are musical tubes. Hit the tubes of different lengths gently with the small striking hammer. Observe that different tubes emit sound of different pitch. The pitch of sound of a freely hung tube depends on its length. The shorter is the tube, the higher is the pitch. Okay, let's try it. I think we should start from here. Okay, it's very high. Wow! So nice, isn't it? Okay, let's move on to the next one. So guys, this is the same as the eco tube, but this is a fish one. Ah! Oh, I was scared by the eye of the fish. It's looking like Pokemon ball, isn't it? Okay, I'm standing at that side. You hear from me till that. From that. Hello, can you hear me? It's echoing a less, but it's echoing. Okay, let's move on to the next one. So guys, this tool is known as the turn faster. Sit on the chair and push the weights away at your full arm length and hold them. Ask your friend to give you a gentle turn. While rotating, bring both the weights close to you. You will turn faster. Away the weights and you turn slower. Repeat this. Every object in rotation conserves its angular momentum, which is the product of its rotational mass and angular speed. As you bring the weights closer, mass of the system gets concentrated, more towards the center, thus reducing the rotational mass. As a result, in order to conserve the angular momentum, the angular speed increases. Okay, let me try this. Push it slow. Okay. Oh my goodness. धीरे धीरे बस. Oh, I don't like speed by rotating. Okay, push me now. Okay, done. I don't want more. Okay, let me get down now. Oh my goodness. Ah. Okay, so let's go to that triangle one. So guys, this is known as perception of depth. Look at the color plates placed at different distances from you. Look through the peephole. Which is here. Only one eye. The disjointed plates appear to be merging together, forming a spectacular pattern. While looking through both eyes, we get two different images of the object at slightly varying angles. This is analyzed by the brain and enables to distinguish which is near and which is far. On the other hand, while looking through a single eye, the perception of depth is lost and all the plates appear to be on the same plane. Okay, I'm trying to go through this. So guys, I feel like it's moving. Okay, now we will go to the friends. I'm swinging here. I well know this is a swing. I'm sure there is no notes about this one. Okay, let's go. Friends, this is a swing that I can't even sit in. Okay, let's try to sit. Yes, I've sat in it now. This is a tire swing. I don't know what it is made for. I think it is a swing of. I really like the Eco Tube. I hope that we will find more nice things in the hall. And down there is a pool, but it's very dirty. When I saw it suddenly, I wanted to bath in that one. And there is a fountain in the middle. Friends, I love this view very much. This here is also the pool. I want to bath in this one. Okay, let's go to the motion gallery. This is known as the motion gallery. But please wait a minute, I want to play here. I will just slide down till there. It was too fast. Okay, let's go inside the motion gallery. Oh, summer hobby camp. So friends, you see this one, the small ball moving. So here what we have to do, we have to press this switch to make the ball move faster. Press the switch to observe how a ball traces the locus of a moving point based on a function with changing parameters in a polar coordinator system. The position of a point in terms of x and y in Cartesian coordinate system can also be represented by r, its distance from the pole and E, an angle. The distance r makes the polar axis passing through the pole. Okay, friends, this is a nerve impulse. Okay, I don't want to keep my hands in this because I got a large current and I don't want to do it again. Ow! 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 My hands are burning. I don't want to be like that. So friends, I'm sorry, the mathematics gallery and the whole science park is being closed. No worries, I can show you the rest of the part in part 2. If you like the video, like, subscribe and share. If you want the next part fast, then you can subscribe my channel. Bye for now.